Welcome to Learn Yourself. Today we are going to learn and understand about scattering effect of the light. Under this phenomena, we are going to first study the Tyndall effect, which we have already seen in 9th standard. Let us revise this effect. So this Tyndall effect may arise due to the solution of colloidal suspension. Now what is the meaning of colloidal solution? That is a heterogeneous solution, but this solution seems or appears as a homogeneous solution because the particles of this solution will not be able to see through naked eye. So if there are two solutions with us, for example salt plus water or copper sulfate plus water, and we have milk and water or alone milk will be there, then there are two solutions with us. That was, one is water plus salt and another solution is water and milk. So for this second solution we are adding some of the drops of milk into the water. This solution is a true solution. That means the particles of the solutes are very small, and due to their smaller size they will not be able to scatter the light. Now what is the meaning of scattering of light? For example, these are the particles of solute into the solution. So when light will pass from this solution, this light will scatter due to these particles are coming in its way. So this is a scattering of the light. Now here the particles of the solutes are very small, so they will not show us this phenomena which is known as scattering of the light. But here the particles are big because this solution is heterogeneous solution and not a homogeneous solution, whereas this solution is homogeneous solution. So here we will be able to see the scattering and here we will not be able to see the scattering. So colloidal solutions are coming under this category, under heterogeneous solution. So when we have colloidal solution with us and when we will put a torch like this, then we will be able to see a light path clearly. That is how the light rays are passing from the solution, and this effect is known as Tyndall effect. Tyndall effect means we'll be able to see the path of light clearly through the medium. That is a Tyndall effect. So the phenomena of scattering of light by colloidal particles give rise to Tyndall effect. For example, sunlight passes through canopy of dense forest. So when scattering of light happens through any medium, that is known as Tyndall effect. Under the scattering of light, the first phenomena is why sky appears blue to us. So the molecules of air and other particles in atmosphere have size smaller than the wavelength of visible light. So atmospheric particles are very smaller, and these smaller particles are scattering blue light maximum. These particles are scattering light of shorter wavelength, and that is blue. So small particles are scattering light which has short wavelength, then the longer wavelength red. Red light wavelength is 1.8 times greater than the blue light. So red light's wavelength is more, and that's why whatever shorter wavelength we will be able to see in the sky is blue color light, and that's why this blue color light will scatter through the atmospheric particles and that will reaches till us, and that's why we'll be able to see the sky color blue. If there would be no atmosphere on earth, then the sky would have appeared dark to us, and that's why sky appears dark to the passenger who are flying at height, because at that prominent height there are no particles who will scatter the light. So that's why for them the sky is black, whereas for us, where the light scattered through a small particles, and they are scattering the blue light maximum because they are scattering the light which has a shorter wavelength and not the longer wavelength, and that is blue. So that's why we'll be able to see the blue color. Scattering of light. This phenomena we are going to understand with the help of activity 11.3. In this activity, this is the setup in which we have taken a source of light which is white color. After that we have taken two lenses. This both lenses are converging lens, that means they are convex lens. And we required here converging action, that means it needs to collect all the rays, and at the end of the activity will be able to get one point size image or one point where we can see the color of the light. So these two lenses we have taken. This is lens 1 and this is lens 2. Both are converging convex lens which will give us converging effect. After this lens we have placed here glass tank. We need to see the color of light which will pass from this tank, so it needs to be glass. That's why it should be transparent and we'll be able to see the color of the light from outside. After that we have placed here cardboard. From that in middle the hole is there from where the rays will pass and again fall on the second converging lens, and after at the last we'll be able to get the point size image of the light beam, and here we'll be able to see the color of the light. So in this tank we have taken 2 liters of water and we have added 1 to 2 ml of concentrated sulfuric acid. Once everything is ready, we are going to add sodium thiosulphate, that is 200 gram of sodium thiosulphate. Once we will add this, after 1 to 2 minutes our reaction will start and we will be able to see that here the white color beam will change and it will continuously changing its color. So let us understand how and why. So in this activity, these two things we are taking it into the tank, and once this setup is ready we are going to add sodium thiosulphate. So this reaction is going to happen over here, that sodium thiosulphate, that is Na2S2O3 will react with sulfuric acid and we will get sulfur, sodium sulfate, sulfur dioxide and water. Here this is important for us, which is sulfur. So sulfur will come out as a precipitate. Sulfur will be a precipitate, and within first 2 minutes the particles will be very small. When it will started to forming the particles into the tank, the particles will be very minute. When the particles are very small, at that time it will scatter a light and it will scatter a blue color light, because particle size is very small, and because of that here we will be able to see blue color light. So first, when particles are very small, we'll be able to see the blue color light. After that, as this reaction will progress, our particles will become bigger. It will become bulgy. So the particle size will be growing continuously. So as this particle will grow, here the color of the light will change, because as the particle will grow and particle size will become bigger and bigger, they will scatter a light which has a longer wavelength. Blue color light or the violet light has a smaller wavelength. So after this, after some time, we'll be able to see the orange color light. After that, when particles will become even bigger, they will scatter a light which has a color, that is crimson. And at the last, when particles are big enough, and they will scatter the light which has a maximum wavelength, and that is color red. So at last we'll be able to see the red color light over here. So this happens because of the particle size. As the continuously particles are growing bigger and bigger, here also color of the light will change. Smaller particles will scatter a light which has a short wavelength, so that is blue. And as the particles will grow in size, it will scatter a longer wavelength light, and that's why we'll be able to see this change in color, that it will go from orange to crimson and crimson to red. Now our second phenomena is color of the sun at sunset and sunrise. Earlier we have seen that why we will be able to see the color of the sky is blue. Then what is the reason that why at sunset and sunrise we'll be able to see the sky color light pink or reddish, and sun will appear to us is red. So when sun is at overhead and when the sun is at the horizon. So when at the noon, when sun is at the overhead, the distance from sun to earth is comparatively less, when sun is at the horizon, because we know that Earth is not a complete sphere. So that's why this distance will be less compared to this distance. So sun will be relatively near to us when it is at our overhead. But when it is at the horizon, then it is relatively far compared to the afternoon's position. So at noon, the sun rays travel shorter distance compared to when the sun will be at the horizon. So at noon, sun appears white because as a little blue and violet light will be there that will scatter away and it will appear as white. Whereas when the sun is at the horizon, most of the blue light and the shorter wavelength light are scattered away by the particles, and the light will reaches till us is only of longer wavelength. Now longer wavelength light is red color, so light reaches till us are of longer wavelength, and that is red. So that's why we see red sun at sunrise and sunset. So here distance is the main reason when the sun is at the overhead and when sun is at the horizon. When it is at the overhead, the blue and violet light, the little bit of that light will scattered and sun will appears to us white. Whereas here at the horizon, the most of the blue and violet light will scattered away and it will not reaches till us because this distance is more. So the light will reaches till us is only of longer wavelength light, and that is red. So that is why we'll be able to see the red color at sunrise and sunset, whereas the white color of the sun at noon.